Well, hello there, everybody. I'm so glad you tuned in. This video will be about graphing sine and cosine functions using the famously titled 5-point method. All right, so that's what we're going to talk about here. I'll give you a couple of examples to look at. First off, I want to make sure that everyone's very clear on the form of the trigonometric functions that we will be using. There it is. Now, the general public might look at this. By the way, if you're from the general public, welcome. I'm glad you're here. This form that we are using in our textbook is a little bit different than many textbooks. It has this k value, which controls the frequency of the controls the period of the graph, already factored out of the expression for x. This is nice. It's sort of a user-friendly version of a trigonometric function, which is nice because it reveals explicitly what the phase shift value is. You don't have to divide in order to find the beginning point of one cycle. So it's kind of nice that way. Anyway, that's what our textbook uses, so that's what I'll be using in this little video. Okie dokie. Let's just quickly break down what all of those parameters do, just as a reminder. A is the amplitude. Talks about the total vertical change of the graph. The period is 2 pi divided by k. Please make sure you observe the period is not equal to k. Period is equal to 2 pi divided by k. Okay. The B there is the phase shift, which is more practically thought of, in my opinion, as the beginning of one cycle. All right, especially since our job is to graph it, we want to know where the beginning of one cycle starts, and that's at B. Very nice. The D, that vertical shift, I want to introduce right at the beginning that we should think of that D number, that constant in the equation, you might say, as the vertical shift, yes, but it is the horizontal midline of the graph. It's sort of like a displaced x-axis being shifted up or down. And that's really important when we start plotting some of the key points for these graphs there. So please think of D, that number there, as representing the horizontal midline of the graph. Okay, so before we get into an example, I want to give you a couple of general strategies here. And this first one I find extremely helpful. And that is this: before we do anything else to graph your function, first figure out what the period of the graph is and divide that number by 4. This 1/4 period should become the increment for your x scale. That's how far apart your little tick values on your x axis should be, is this 1/4 of the period. Okay? Very helpful to do this, and you'll see why in a couple of examples. I hope it'll become obvious. It avoids so much confusion about scaling the x-axis for these trig functions. When you start planning in radians, pi over 6, pi over 4, pi over 3, those values, those increments around the unit circle are not always the same. In other words, the difference between 0 and pi over 6 is not the same distance as between pi over 6 and pi over 4. So if you're trying to put all those numbers on your x-axis, you're going to get confused. Okay? So this actually makes graphing much easier by focusing on the things that are really important for your graph. Next, the 5-point method really begins with B. That's the beginning of one cycle, and the second point of your 5-point method is the end of the cycle, and you get that by adding B plus the period. So find B, and then B plus the period, which you just found out earlier, and that's the first and second points of your graph. Pretty nice. You've got 2 out of 5 then. Then the third and fourth and fifth points are the 1/2, 1/4, and 3/4 points, respectively, of your cycle. And those depend a little bit on whether or not you're graphing sine or cosine. And I will have an example of each to show you how they differ from each other. Okay? Well, take a look at those. That first tip, number 1 there, is tremendously helpful. But the 5-point method is also a very useful and simple way to graph these functions. Let's take a look at an example of sine. And I've got one with a lot of stuff in it to think on there. Negative sine of 2 times x minus pi over 4 plus 1. So if you look at that, all that stuff in there, and think first off, what's the period? The period is 2 pi divided by k. K equals 2 for our equation here. So 2 pi divided by 2 is just a nice friendly pi for the period. Okay, next find B. B is right there. Remember, x minus pi over 4 means that the graph has been shifted to the right. So x minus pi over 4 means b equals positive pi over 4. All right, so that means then if we found period and the beginning of one cycle, the end of one cycle is just the sum of those two numbers, which for our case here, pi plus pi over 4 equals 5 pi over 4. So we got the beginning and we got the end, and we're just about ready to go. I want to make another observation here. That negative sign is definitely worth looking at, but also the amplitude of this function doesn't have a number. The amplitude in this case is 1. That means it goes 1 unit above and 1 unit below the midline of the graph, which the plus 1 at the end of the equation means that the midline has been shifted up 1 unit. So we'll definitely need to observe that when we start graphing. Also, it's that negative sign there. What it means is the graph has been reflected across the x-axis, and the general shape of that negative sine curve is like that little red squiggle there. Okay, let's think about the x-axis here. I've got my increments of pi over 4, which is the period divided by 4. So pi over 4, 2 pi over 4, 3, 4, and 5 pi over 4 is my x-axis points. I don't care about any other fractions there. And I notice I'm not even bothering to reduce the fractions 2 pi over 4 or 4 pi over 4. It's fine the way it is. We're just trying to get the most sensible graph and that we can do here. So just leave it like that is fine. I've also sketched out the horizontal midline, right? That's our plus 1. And so our first point is right on that midline at b, pi over 4. So there you go. Marked off the first point, and then let's mark off the second point, which is the end of the cycle, right there at 5 pi over 4. So our scaling there makes it really easy to locate these points. The third point is right in the middle, 3 pi over 4. And all three of those points for a sine curve are on the midline. So remember that. Your first 3 points of the 5-point method are on the midline for a sine curve. Nice to know. The fourth point for this sine curve is a minimum value, because our shape being a negative sign, it goes down first and then back up. And so our fourth point is a minimum and our fifth point is a maximum. So we got our 5 points. You can sort of see what's going to happen when I connect those like that. So there you go. There's our one cycle of that sine curve. So plotting ahead and doing this, taking the period divided by 4 for your x increments is a tremendously helpful tool. Let's look at another example for cosine. All right. So here's a cosine curve, and I've changed up the style of numbers here just to give you a different look at some things. Here it's 6 times cosine of pi over 6 times x plus 2. So our k value in this equation is a fraction of pi over 6. That's a little bit different. Also, the horizontal shift, or phase shift, is at x equals -2, an integer. So it appears that we are not going to be using any fractions of pi on our x-axis, and that is true. When we figure out the period of this graph, 2 pi over k, 2 pi over pi over 6, you work that out a little bit, and you're going to get the period to equal 12. Okay, that's nice. And when you think about b being -2 and the period equaling 12, when you add those together, you get a nice friendly integer of 10. So yes, indeed, our x-axis will begin at -2 and end at +10. So there's no worries about fractions of pi for this graph. Okay, let's also observe that the amplitude is 6 and that this is a positive cosine curve, so its general shape looks like that. It begins and ends at the maximum point, and then the minimum point is halfway through it. So when we think about scaling the x-axis, starting at -2, and then going up by increments of 1/4 of the period, which is 12 divided by 4 is 3. So we start off at -2, and then we go to +1. And then we go to 4, and then to 7, and 10 is the last point that we're going to worry about, which is the end of the cycle. Okay? So you can see the convenience of taking the period and dividing by 4 and using that as the scaling factor for your x-axis. Now, let's mark off the y-axis too. +6 to -6, and cosine starting at the top there and shifted to the left 2 units gives us our first point there at -2, 6. All right, there's our first point. The second point is at the end there at the cycle at the maximum point. So 10, 6 is our second point, the end of one cycle. The third point is halfway through, which in this case for cosine is at the minimum of the curve right there at x equals 4. So 4, -6 is our next point. And then the 1/4 and 3/4 points are right there on the midline, halfway between those three that we just already marked off. So the scaling here makes it really easy to nail down these points. And there we go. We'll just connect them with a curve, and ta-da! There's our beautiful cosine curve. And so I hope that you practice this 5-point method and taking your period divided by 4 to use as the x scaling factor. And I hope that makes your work a little bit easier, a little bit more sensible. You're doing some wonderful mathematics to sketch these out by hand. So please be well, and let's go do some math.